Hey everybody, John Doherty here. I'm at Tacoma Community College today. Looking forward to a presentation to a bunch of inquiring and energetic students. Looks like a good crowd showing up. We're going to be talking about climate, carbon dioxide, what we can do about it, what's real, what's not. Really looking forward to the time.
John has a talk program, a regular climate talk program on Tacoma's FM station KTAW 101.9. He's an Evergreen State College graduate. And so without further ado, I'd like to thank John and introduce him to give the talk, Climate Change, What's Real and What to Do. Thanks, John, for being here.
The purpose of this picture is a beautiful picture, I think. It's taken by NASA. And the thing that I find of most value in this picture is that's sunrise from the space station. And that little thin band there is the atmosphere. That's all we've got. It's if the Earth were the size of a basketball, the atmosphere would be 1/8 of an inch thick. As human beings, we have difficulties with scale. And so it's easy to think, well, there's lots of air and we don't need to worry about it, and there's lots of water, there's oceans, and so on and so forth. So speaking of the ocean, I mean, if the Earth were the size of a basketball, the ocean would just be enough to make the basketball wet. So these are very limited resources. We need to be taking good care of them, and the reality is we are not. The Earth is really a little tiny place floating around out in space, and the reality is we're not taking good care of it. So let's talk about, I'm going to talk a little bit about science here. The science really is settled. And every once in a while when I say, well, the science is settled, somebody says, well, science is never really settled. Well, yeah, I take the point. But the connection, for instance, between carbon emissions, which is what we're going to be talking about a lot here, the connection between that and climate change, global warming in particular, is just as robust as the connection between smoking cigarettes, for instance, and cancer. So scientists will adapt as they learn more, as we gather more data, but the science of what's going on with climate change is pretty well settled. And there's nothing tricky about it at all. There's nothing about climate change, global warming, that the average high school chemistry or physics student couldn't understand easily. So, in fact, scientists have been talking about the impact of carbon dioxide on the atmosphere since the late 19th century, actually. And it was in the 30s that scientists started actually taking measurements and demonstrating empirically that the Earth was actually warming. So, quickly here, there's a couple charts in here, and I'm going to take a second to make sure that we understand the chart. Charts can be boring, but I think they're really critically important to understanding what we're talking about, and here's why. It's very easy to cherry pick a few data points off of a data set and say, well, look, see, the Earth isn't warming. And I'll give you an example of that as we look at the slides. So just bear with me while we take about 5 minutes here and look at the science. So first of all, greenhouse effect. Greenhouse effect is necessary for human existence. And just briefly, what happens is the sun's energy comes in, it passes through the atmosphere without affecting the atmosphere because of the form of energy it's in. It strikes the Earth, it warms the Earth, that warmth from the Earth is radiated back out into the atmosphere, and if it weren't for the greenhouse effect, it would all just go back out into space, and we would be 70 degrees Fahrenheit colder than we are now, which, human habitation would not be possible under those circumstances. So it's not the greenhouse effect is good or bad, it's just that it is, and if we didn't have it, we wouldn't be here. Okay, so we change the greenhouse effect by what we put out in the atmosphere. Now, some of it makes the Earth cooler, like the aerosols, tiny particles that go out into the atmosphere. They actually reflect light back out into space, so they have a cooling effect. But the gases that form this greenhouse process, as we increase those gases, the greenhouse effect is exacerbated, it's increased, and that's what's going on right now. So the Earth is warming, and that's why. So let's take a look historically here. So let's just take a second to understand this chart. First of all, it goes back 400,000 years, significant amount of time by anybody's form of reckoning. The axis on the left-hand side is the concentration of carbon dioxide per million parts. And so you can see that over time, over the last 400,000 years, the most we've ever seen in terms of carbon dioxide concentrations is about 300. And usually it's lower than that. It's maybe 250 or so on average, something like that. Okay, where that arrow is where we are today. And you can see in the upper left-hand corner that as of April 1, the readings were over 411 parts per million. The last time that the Earth experienced that much carbon dioxide in the atmosphere was over 3 million years ago. So this, some people will try and tell you, well, this is natural and this is, climate's always changing, blah, blah, blah. And the reality is we're experiencing something right now that is absolutely unique, certainly in human history, and it's unique for hundreds of thousands of years in the past. This chart, once again on the right-hand side, lower right-hand side, we have the carbon dioxide concentrations, and above it we have temperature. And the purpose of this chart, very simply, is to show the correlation between carbon dioxide in the atmosphere and what the temperature is on the Earth. By the way, I would ask, how do we know what the temperature was or carbon dioxide concentrations were 400,000 years ago? We know it from the ice in Antarctica. There's a team of Russians, French, and Americans that have been taking ice cores down there. The ice has little bubbles of atmosphere in it, so when we drill down there, we know what the atmosphere was doing 400,000 years ago and on up. They're down about almost 4 kilometers into the ice, and that's where we get the 400,000 years. So you can see there is a very close correlation between carbon dioxide and the Earth's temperature. You can also see the scale on the bottom is not big enough to manage what carbon dioxide is doing in the atmosphere right now. So you can see once again that the historical natural correlation between carbon dioxide and the Earth's temperature is no longer operative. Okay, so let's take a little shorter time scale, and this time scale is back to 300, so we're talking 1,700 years or so. And you can see the temperature being fairly stable over that time scale. As at the part closer to modern times, where it's a little bit colder, that's referred to as a mini ice age. So it was really chilly. I mean, it was tough living in Europe, for instance. But it's also an illustration that very small changes in temperature can have very big impacts. And the red there is actual temperature measurements. The other ones are sourced from various methods. And you can see that the temperature really started heading towards up with the start of the Industrial Revolution, which was the time when we started putting carbon dioxide into the atmosphere. Prior to that, the carbon dioxide cycle was perfectly natural. It'd go up in the air, it'd come back, it'd be photosynthesized by plants. The plants would be used in some way or would just decay, releasing carbon dioxide, and that cycle was natural and it was stable. So let's take a quick look at this is a NASA animation that gives us an idea of what temperature has been doing over the last 100 years or so. So amber is warmer, blue is cooler, and let's just watch it here for a second. One of the things you'll notice is that the northern hemisphere is, especially up around the Arctic, is warming more than other parts of the world. Another thing that I think is important to note there is that the climate, nothing about the climate changes in a straight line. In other words, the temperature doesn't increase all over the world. The sea level doesn't increase at the same rate all over the world. The temperature doesn't change all over the world. So different areas are impacted in different ways. Some places will be colder, some places will be hotter, some places will be wetter, some places will be drier. So let's talk about natural, just for a second here, about natural causes for climate change. So volcanic eruptions. The volcanoes go up, they put particles in the air that shades the earth, in one way of thinking about it. And so things cool off after volcanic eruptions. Ocean currents, probably everybody here is heard the expression El Nino and El Nina. Ocean currents that have a significant effect on climate around the earth. So ocean currents absolutely have a role in what the average temperatures in the climate is doing. Earth orbital changes. This is kind of an interesting one to me. The charts that we looked at with temperature on it, I didn't point it out at the time, but those high temperatures are about 100,000 years apart. And the Earth's orbit is not, it's not stable in the sense that we're always the same distance from the sun. There is about a 13% difference between the furthest and the closest, and when we're closest to the sun, it gets warmer, and that cycle happens once every 100,000 years. Solar variation. The sun is not always putting out the same amount of energy, and the changes are significant. The effect is felt here on Earth and can be measured here on Earth. And the tilt of the Earth's axis also affects what the average temperature is around the Earth. The Earth is wobbling. It's a very slow wobble. I forget what it is, but it's like 10, 15,000 years, something like that. So all of these things impact the climate and the temperature on the Earth. Okay, here's my whole point of belaboring this, and that is the science deniers like to point to these things and say, well, look, this is a natural cycle, or the solar variation is what's causing these changes. There are literally tens of thousands of scientists studying the environment, and trust me, those scientists are paying attention to these other possible natural causes of climate change. I mean, you wouldn't be much of a scientist if you just missed something obvious that some guy sitting in his basement with a laptop and a connection to the internet could figure out. So while these are real, they really have nothing to do with what's going on with the climate right now. I'll just use one of these real quickly, solar variation. The temperature and the solar variation were tracking pretty closely up until about 30 or 40 years ago. And you look at a chart of those two temperatures, or those two factors, and it's real clear that those two diverged about 30, 40 years ago. So solar energy has been going down and temperature has been going up. By the way, when I mentioned that chart, one of the things I'm really hoping that all of you, and I'll settle for 90% of you, all of you will dig in and do your homework on what's going on with the climate, because this is such a critical issue, and it's especially critical for you folks because you're 18, 19, 20, 21 years old. You're going to live through all this stuff that we're talking about. I'm not. I'm going to be gone here in another, pick a number. But to understand what's going on and to be able to make a difference, you really have to have done your homework. So don't take the easy route and just pick something and say, well, I believe that because of what somebody else has said or because of my political opinions and so on. Really want you to dig in. Okay, let's talk a little bit about what's going on right here in Washington State. Ocean acidification is a part of carbon dioxide pollution. And what happens is about 50% of the carbon dioxide we're emitting goes into the atmosphere, about 25% of it is reabsorbed back into the earth, and 25% of it's going into the ocean. So when you mix carbon dioxide with seawater, the result is carbonic acid. So the ocean is becoming more acidic. The Puget Sound actually is one of the poster children for this acidification for a number of reasons. which I'm not going to go into here, but it's affecting the shellfish industry. It's significantly, like oyster farmers now have to go somewhere else to get their larvae because of the water is so acidic that the larvae can't develop their shells when they're first starting out. So, and it's affecting other sea life too, but the shellfish is the ones that are being most affected. Okay, wildfires. My guess is pretty much all of you were here last summer, and it was, I would say, unpleasant to say the least, and actually dangerous to people with respiratory issues or the aged people or people who were sick with something. I heard somebody say last summer, well, I guess we better get used to it because it's the new normal. No, it is not the new normal. This is if I'll make a chart in the air here, this is what's going on. So we can expect over time, and remembering I said nothing happens in a straight line. Over time, we can expect that the wildfire season is going to become longer and more intense. In March, we had 51 wildfires going in the state of Washington already. So, of course, what happens is pretty simple. If it's warmer and drier, the forests and the grasslands burn more easily. The Forest Service says that normally they don't see the number of forest fires or the wildfires that we had in March. They don't see those until into August or September. So the summer should be a doozy. Okay, floods. One of the things I want to mention here real quickly is all of the data that I've been giving you here is from reliable sources. So what's a reliable source? It's a source where the scientists are trained and the work that they do gets published in peer-reviewed academic journals and science journals. You can put anything you want to out on the internet, and you guys know as well as I do, it doesn't matter what axe you've got to grind, you can find somebody on the internet that says, yeah, that's true. Anybody here ever heard of alien reptilian invaders or shape changers? Yeah, that's it. The shape changer part is really important because if they were just alien reptilians, we'd be able to see them right away, right? If you don't know about this thought, I encourage you to go on YouTube and check it out. Alien reptilian shapeshifters. I went on one site last night just looking at this. It's had over 4 million views. So my point here is be very careful where you get your data from. Now, the example I gave you here, I mean, there was one other point that guy that made last night too. The moon is actually hollow, and that is where the aliens are sending their radio waves out to control how we think. So according to his worldview, if you think, well, that's not true, that's just the alien radio waves changing your mind for you. So anyway, I won't belabor that point any further than just to say, please be very careful when you're doing your homework, which you've all tacitly agreed to do on climate, then just be careful where you're getting your data from, okay? All right, so the data that I'm going to give you here is from NOAA. It does an incredible amount of research. And going on the NASA websites, there's a website called climate.gov. I mean, the stuff that's on there is fascinating and it's reliable. So NOAA has been tracking crests on the Puyallup River for over 100 years. The data was just in tabular format. I downloaded it, sorted it, massaged it, and here's what I found. 8 of the 10 highest crests on the Puyallup River have happened since 2006, and that's in over 100 years. So the water is coming down. The glaciers on Mount Rainier are receding. They're melting. We're having wetter winters, and we're having hotter, drier summers. And the net effect of that on the Puyallup River and all the other rivers, that's not fair to say. There are some rivers that are not experiencing this, but most of the rivers in Washington State are flooding higher, more frequently, and earlier than they have historically. This picture here is taken over in Milton, so it's not Houston or Bangladesh. It's just right down the road here. So we have this expression, canary in the coal mine, which I think is a very useful connection, thought. So just real briefly, back in the bad old days, miners used to take a canary down in a bird cage into the coal mine, and if the canary died, then that was an indication that there was something wrong with the air and they should get out of there. Okay, glaciers for us can be viewed as a canary in the coal mine. Washington State has a lot of glaciers, over 400 actually. And of those 400 in the last 30 or 40 years, 20 of them have gone extinct. All of them are decreasing in size. So this particular photograph here, the one on the left, 1905, the Lillian Glacier, it's just right over there, about 30, 40 miles away. That's what it looked like in 1905. And then the right-hand picture is what it looks like, it's what it looked like in 2010. So back in the 60s and 70s, we had this expression, you don't have to be a weatherman to know which way the wind's blowing. In fact, Bob Dylan wrote a song on that theme. And so my point here is, you don't have to be a climate scientist to see the canary in the coal mine. I mean, the glaciers are just so obvious. I mean, Glacier National Park has lost a huge number of glaciers, and the expectation is that by the turn of this century, all of the glaciers in Glacier National Park are going to be gone. Some of the stats here, Mount Rainier's lost 24% of its ice, 25% of its ice. Mount Adams has lost 50% of its ice. So one of the things I could wonder is, the glaciers are shrinking, who cares? Those glaciers are a water reservoir that our ecosystems here have relied on over the centuries. And what they do in the summertime, they keep the streams going. They keep an adequate water flow going for the wildlife that live there, for people who have lived off the salmon historically. And as the glaciers recede, the summer water level is low and the temperature is high, upsetting the balance of the whole deal there. So the glaciers going away it's a big deal. And worldwide, the total water content of glaciers is down about 25% already. And part of the bad news is, once again, nothing happens in a straight line. That loss of water in the glaciers is increasing. The rate of loss of ice is increasing. It's not a straight line. So certainly something for us to be concerned about. Okay. Quickly summarizing what we're looking at here in the Pacific Northwest, we're looking at wetter winters, drier, hotter summers, reduced snowpack. The snowpack is related to the points that I just made about the glaciers. Warmer temperatures, rising sea level. The estimate is that Puget Sound, in the last 100 years, that the water level has already risen 7 inches. Sounds like a very little bit, but it's significant, and the city of Tacoma is already making plans for significant parts of the tide flats to be underwater at high tides by 2050, which, from my way of reckoning time, isn't very far away. The reason I smiled there is I can remember when I was 20, 20 years seemed like a long time. Right now it doesn't seem like so long, and my guess is that you guys will experience the same phenomenon. Climate refugees. Really, what's going on our southern border is very closely related to climate. Climate change is almost always associated with civil unrest, especially in countries, places where the resources to adapt are limited. Let me just make a quick point on that one here. The United States, so let's talk about per capita footprints for a second. Per capita footprint of carbon dioxide that we're putting out in the atmosphere. And I really think that per capita is the only accurate and useful way of talking about how much carbon dioxide is going out into the atmosphere. Now, it is true that Chinese right now are putting out a lot more carbon dioxide as a country than we are, but they also have 4 times or so, 3 or 4 times or so the population that we have. And per capita, we are putting out way more carbon dioxide than China is. And we're putting out way, 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 way more than India is. So when you hear somebody saying, well, why should we cut back on our emissions when China and India aren't, that's really a bogus argument. And by the way, China is undertaking some real efforts to cut back on their emissions. And the primary reason for that is not so much climate change, it's their environment in so many of their cities because of making electricity with coal has just become toxic, and it's a huge problem. So the toxicity of fossil fuels is a whole separate discussion. But to just finish up this point here, the top 10% of carbon emitters in the world produce 90% of the carbon dioxide. So what that means is that the people who are suffering the most are the people who are not putting the carbon dioxide out there. So we essentially got rich by burning fossil fuels. Those countries are not rich. They don't burn fossil fuels. Other than some of the oil countries like Bahrain and Qatar, the United States per capita has got the biggest carbon dioxide footprint in the world. So I think it's up to us to show leadership, dredging off into politics just a second here. It's up to us to show leadership in the world because we are really responsible for a big chunk of what's going on, and we're responsible for the suffering that a lot of people are experiencing. Okay, so we can ask, and it's a very common thing to ask, what can we do? I'll answer that in two different ways. Number one is, what can we do as individuals? And I'm going to give you a phone number here in a bit that you can text, and I'll send you this document plus a bunch of other stuff. If you text me, I can send you a link to it. And the reason I'm doing that, it's 8 or 9 pages, and save a tree, you get it. So as individuals, we're responsible for about a third. Let me put it this way: we have control of about a third of the carbon dioxide that's going out there. So if we drive electric car or we drive less, we turn down our thermostat, we put solar on our house, we use mass transportation, the list of things that we can do as individuals goes on and on and on. And that's what this 110 ways to reduce your carbon footprint is about. It was actually kind of fun putting it together. I learned a lot doing it, and I hope you'll send me a text so I can send it to you. That's 1/3. The other 2/3 is stuff that's out of our control. It's not anything that you or I as individuals can have an impact on. So I'm talking about industry, I'm talking about electricity production, I'm talking about cement manufacture, those kind of things. So the only way we can address those things is politically. And so when the question is asked, what can I do? One of the answers is, you got to get politically active. You have to make your voice heard. And so then to me that brings up the question, okay, how do I do that? Well, the very first thing is to get over the barrier to doing something. I mean, I experienced this barrier myself. The first time I called up an elected representative, there's a lot of thoughts going around in my head like, well, what difference does my voice make? Just one thing. I'm probably going to irritate them back there. They probably already agree with me anyway. I mean, I could come up with a list of about 10 or 15 reasons to not make that phone call. Once I got past that barrier, it's easy, it's straightforward, and it's effective in this kind of way. The elected representatives keep track on a daily basis of what calls and emails they're getting. And by the way, just as an aside, email and phone calls are the very best way to communicate with them because they're fast. If you send them a letter and it's in an envelope, it gets held up for 6 weeks for security because there may be some dangerous thing inside the envelope. So those numbers are toted up for the day, and the elected representative will know, okay, I got 23 phone calls today from people saying that they're concerned about climate change or immigration or whatever the subject should be. So I would say do it. There's another thing you can do too. As an individual, we've got limited value. I mean, if I was forming up a basketball team and one side had 5 players plus 5 on the bench, and I had 1 player, chances are it wouldn't go that well. And the same thing is true in politics. So there are all kinds of organizations that you can join that care about the environment, care about the climate. They're active, and even just joining makes a difference. I know you guys are all busy, you're working hard, maybe have a job to help support yourself, kids at home, who knows what. You're busy. But just joining makes a difference. So, for instance, Citizens Climate Lobby, we go back to Washington, D.C. every June and every November and directly lobby elected representatives back there. By that I mean we get together in our little groups and we go to the offices of the representatives and the senators and we lobby them about climate. One of the things we can say is, well, we have 4,000 members in the state of Washington that are part of our organization. We have 112,000 members all over the United States. So those numbers make a difference. If we go in and say, well, you know, we got 20, 30 people, they're like, okay, well, thanks for the visit. So join, be active, and even if you can just be a number in it. And I'm not going to belabor what organizations you can join. They're out there. Citizens for a Healthy Bay, Sierra Club, Audubon Society, People for the Puget Sound, the list just goes on. And of course, Citizens Climate Lobby, we're very active, and it's a great way to have your voice heard back in Washington, D.C. We also lobby down in Olympia, by the way. Our focus is on national issues, but we do go down to Olympia. One quick thought on that. If we don't go to Olympia, and what I'm talking about is we as, let's call ourselves ordinary folks, if we don't go to Olympia, don't worry about it. The lobbyists are down there. And I've been down there on lobby days where just plain folks go down there, and the people who are the professional lobbyists they stick out like a sore thumb. They're the guys with the 3-piece suits, the highly shined shoes, the power ties, and their little briefcases. And they're there every day. So, and by the way, I would say most of the companies and other organizations that hire those guys are counting on us to be quiet. So they're there every day. We're not, but we can still have a voice. Okay. I already mentioned do your homework, a couple of the places you can join, emails and phone calls. I put this this link up here, and if you text me, I'll get you the link. The reason I like this link for contacting elected representatives is you don't have to know anything to make it work. You go on this, it asks you for your zip code, and it tells you who your elected representatives are at the national and the state level, and then it directs you to a place where you can leave emails and send them. So you can make your voice heard with very little effort. So there is a bill in the U.S. House of Representatives. It's called the Energy Innovation and Carbon Dividend Act. I would encourage you to take a look at it. The economists say that one of the most effective ways that we can reduce the consumption of fossil fuels is by increasing the price of them. So the process that Citizens Climate Lobby has been pushing for and endorsing for a long time does that. The moment we talk about putting a price on carbon, people want to know where the money's going to go. And that's a great question, and it's actually one of the key questions to the whole deal. And the way that we're proposing, and I think is a way that has the most likelihood of success, is that those funds they're returned to the populace in the form of a dividend, administered pretty much like Social Security or something like that does. So.
So instead of raising the prices of carbon resources, is there a resource?
Great question, and absolutely. So part of the idea of raising the price of carbon fuels is that it makes clean energy more attractive. So clean energy, we're really blessed here in the Pacific Northwest to have existing hydroelectricity, which is absolutely clean. Right now in Tacoma, the electricity that we're using is 97% hydro. And just an aside, we make more electricity here in the Pacific Northwest with hydro than we use. So we sell about 13% of our total production off into the grid, which is like, okay, good for us. Wind energy, same thing. I mean, there's more than enough wind on the earth to provide electricity for the entire earth, all of our needs. Solar power, same thing. Now, I have solar on my house, and it's providing me about 50% of my electricity. So my electricity bill is basically half of what it used to be. And, you know, by the way, a lot of people think, well, Washington State is cloudy here a lot, solar doesn't really work. Absolutely, it works. And Germany has got worse weather than we do in terms of cloudy days, and they're getting almost 50% of their energy from solar. So solar works. And it also works on a utility-size scale. There is a thing called concentrated solar power, which is basically an array of mirrors which shine up to a focal point, heat, water, or whatever it is you've got up there, and you can produce energy out of that. So the idea of a price on, you got a follow-up question, I can tell. Give me just a second here. The price on carbon, as it becomes more expensive, individuals they can either take that money and pay for more fossil fuel, or they can take that money and say, okay, my next car is going to be electric, or it's going to have better mileage or whatever. So
what about like materials that we use every day, like metals, like what we use for cars?
Yeah.
Things that take like thousands of years to decompose.
Yeah. Well, we're expanding out here a little bit, but I mean, I love where you're going with this. I mean, plastic is a horrible, nasty, ugly. Yeah. So plastic, as you know, is a petroleum product. So my belief is if we increase the price of petroleum, we're also going to increase the price of plastic, and people will start gravitating away from it. There are no magic bullets here. This is an extremely difficult problem politically. So that's the best I can do for you. I mean, I agree with you. This stuff that takes thousands of years to degrade is a horror. And it's also damn near inescapable in the culture we live in. I mean, I'm plastic phobic, but every time I come home from the store, I realize I got plastic in my shopping bag. Is there
anything the Citizens Climate Lobby is doing to make solutions more accessible?
So give me an example of what kind of solutions you're talking about.
Kind of maybe like solar panels or electric cars, which tend to be very expensive.
Yeah, no, I see. So it's to make them more affordable.
Either that or just accessible to the everyday person. Just, there's a lot of solutions, but a lot of times I feel like they're not very accessible to someone.
Yeah. No, it's a good point. So I'll answer in two different ways. I'll answer no and yes. So the no part is we're really focusing on national legislation because state legislation is really limited in how effective it can be because if you put restrictions on something, businesses just have to go to another state to escape those restrictions. So we're really focusing on this national legislation. So that's the no part. The yes part is, yes, we go down to Olympia. There's bills in Olympia right now that are the stuff you're kind of talking about, like relief on sales tax on electric cars and subsidies for installing solar on houses and stuff like that. So absolutely we do that. It's I guess I would say it's a subset of what we do.
What would it take from all of us for the climate to not be in such a critical condition where we have to either like talk about it or we have to enforce from politicians that this is a problem and we have to fix it?
Well, if I understand your question properly, and I'm not 100% sure I do, there isn't any simple answer. I mean, we are going to have there's two parts here. Climate change is a physical issue, and it doesn't It's not political at all. Climate change does not care a bit about what we think or what our politics are. Doing something about it is absolutely political. So let me talk just a second why it's such a problem. There's a guy named Dan Ariely, and I would encourage, I'll have a link to some of his stuff if you text to me. He's a behavioral economist, and he makes the point that if we were to design a problem that human beings are uniquely ill-suited to address, it would be climate change. And so let's take a look at the whys of that. As human beings, we care more about stuff that affects us directly than affects somebody else. So let's do a little mind experiment here. I'll do it and I'll tell you what I got, and you can just make a note. So what do I care more about, a flat tire in my car or a flat tire on somebody's car that I'm passing on the freeway?
Because it affects you?
Pardon?
Because it affects you? Is that the connection you're making?
The connection I'm making is that as human beings, we care more about stuff that's close. We care more about things that are closer to us in time. We care more about things that are closer to us geographically. Which would we care more about? A car bomb going off in Tacoma or a car bomb going off in Islamabad? Anybody here know where Islamabad is? Yeah, so a really enlightened person, a Mother Teresa type, would care about all of them. But most human beings are not like that. So it's an incredibly difficult problem for us to address as human beings, and that's why I'm saying you have to do your homework, you have to be politically active, you have to make changes yourself. Refer back to one of the earlier pictures in my slideshow here. The Earth is a small place, but it's fragmented politically, and it's fragmented culturally and socially. So to address the problem, it's huge. And it's going to take governmental intervention, it's going to take politics, it's going to take a long time. And the reality is that we're already pretty far down the road here. I mean, bad stuff is happening already. And the future, there's not a lot to be cheerful about here. I mean, we really, I hear people saying, oh, well, he's just a climate alarmist. Damn it, we should be alarmed. Okay, so I'm not sure I answered your question, so you want to take another hit at me?
I feel like you answered my question.
Okay, awesome.
I might just add that the scientists seem to think that 350 parts per million carbon dioxide is what we need to keep the systems in stability. And we're at 411, did you say, as of April 1st?
Right.
Yeah, so I don't know if that helps either, but that's what we need to do, and it involves complete overhaul of the energy system. Right?
Well put.
Anyway, other questions?
Thank you. I appreciate that you brought it home to a local level, because a lot of times these climate change is about what's happening all over the world. So I like that. I've heard that food choices that we make can reduce emissions or contribute to that. Could you talk about that, please?
Yeah, sure. Absolutely true. And absolutely true big time, actually. So the fossil fuels pollution are probably number one on the list of things that human beings are doing, but it's just barely number one. So food production is a huge part of it. I mean, I was just looking at some stats this morning that, just the industrial animal operations are producing a huge amount of greenhouse gases. And of course, those gases are mostly methane, and methane is about 20 times more insidious as a greenhouse gas than carbon dioxide is. So, yeah, absolutely. Food is a big part of this. So I've changed my own diets primarily for this reason. I'm not a vegan, but you can see it from here. So there's a book. It's called Drawdown. If you want to dig deeper into that really good question that was just asked, get the book Drawdown, and it's a very rigorously put together book that talks about all the many things that can be done to address climate change. And the list literally goes on and on. Deforestation, food production. The garment industry is actually responsible for about 8% of the global carbon dioxide pollution that we're experiencing. So part of the reason I love that question is because it does trigger this notion like, yeah, let's do our homework. Let's really know. And I also, I'm getting some sense here that people do want to know how they can change their own behaviors in a way that makes a difference. So that reading the book Drawdown will point you both to individual and political ways of possibly making a difference. Oh, well, never mind. Yeah, gotcha.
Hi there, thank you for your presentation. I have a question for you as a presenter. Is fear and negativity the best emotion to elicit in the greater population? Fear cripples the mind. It makes people lose energy, motivation, get depressed, and lose the spark of creativity we need to solve our problems. Your presentation focuses on what might go wrong in the future and doesn't include anything about what might go right. So again, is fear and negativity the best emotion to elicit in the greater population to solve this problem?
Yeah, there's one of those challenging questions that I was talking about a little earlier. Well, it's a good point, and there are various schools of thought on how to approach this. I've been looking at the problem for a long time. Well, not a long time, 3 or 4 years since I first started digging into it. And Winston Churchill, prior to the start of World War II, when things were looking pretty grim, he said, "I can only offer you blood, sweat, and tears," which sounds like a pretty fear-based negative message to me. But it was also an honest message. So I struggle personally, and I'm just speaking personally here, I struggle personally with exactly the question you're asking. I find myself being pretty gloomy, being depressed sometimes. In fact, I went to a workshop up in Seattle a couple weeks ago about climate despair. That was the topic of it. It's actually a thing, which I didn't realize, that it's affecting a lot of people, because when we look realistically at what's going on, it's easy to go into the downer mode. There are some good things happening. There are some good things happening down in the legislature in the state of Washington. The reality is, though, that all of the good things that are happening aren't anywhere near close enough to addressing what we got to do. Look, so take 2016 Climate Accord. There is probably only one country out of the 190 that signed that agreement that are going to meet their commitments to achieving that goal. So I guess the mode I'm in is calling it out the way I see it.
Hello, yeah, my name is Marquise Taylor. So my last question is, how much do you expect an average person to put towards the climate change, and how much do you think will it take to make that climate change?
Okay, so if I understand the question correctly, how much am I suggesting each individual should contribute to this effort? Is that a fair summary of your question?
That's what I believe what you would want, right?
Yeah. Yeah. Well, part of the reason that I offered a spectrum of possibilities is because different people can contribute different things. I mean, very few people are going to give as much of their life and energy to caring about the climate as the activists do. I mean, we've got our lives. I mean, you guys are looking at your futures, your educations, and so on and so forth. So what I got to say is, I don't care what you do or how much you do, just do something. Even if it's just having a conversation with a friend or family member or something like that. Ask yourself the questions, watch the documentaries, and if you can do a lot, do a lot. If you can't do a lot, just do what you can.
And so how much will it take to make that change?
So what parameter are we using to measure when you say how much will it take?
I guess we're talking about carbon.
Well, if I'll take a hit at kind of an answer here. if we stopped putting carbon dioxide out in the atmosphere right now, zero, done, gone, all over the world, the climate would continue to warm. And that is because those gases are out there, and carbon dioxide stays out there for a long, long time. When I say long time, I'm talking about thousands of years. So if we stop producing carbon dioxide right now, it would, unless there was some other technology that was used to take the carbon dioxide out of the air, the Earth would be uncomfortably warm for centuries. So there's no quick fix here. What we're really talking about, to get back to your point, what we're really talking about is how bad is it going to get?
Do you know if there's changes being done within the technology to stop the carbon from polluting the air?
Well, there's a whole bunch of technology out there. There's carbon sequestration, which is one of them, that actually takes the carbon dioxide out of the air, and it can be pumped down in the earth or used for industrial purposes or something like that. So that's one of them. It would take thousands and thousands of those all over the earth and cost trillions of dollars to do them. So really, they're not practical in implementing. I mean, they're practical because they can do it. There's one up in British Columbia right now that's taking carbon dioxide out of the air. Another one that's proposed is putting particles out in the atmosphere to reflect sunlight back. I mean, it's technically feasible, but just as politically challenging as all the rest of this stuff is. Plus, sulfur dioxide is what they're talking about putting out there, and we really don't know what the ramifications are of putting carbon dioxide out in the atmosphere. So the short version is there's no easy fix here, and we're pretty far down the road already.
Thank you, John, for being here. And I do want to invite everyone outside when this is over to enjoy lunch. Could we give him a round of applause for being here?
Thank you. So there we go. What a great day with a great bunch of students. Some really attentive folks there. A lot of really good questions for a follow-up. And pretty much of a sellout crowd. So I was very pleased with how the day went and with the level of engagement. And really, when we think about it, it's folks of their age that are really going to have to carry the water and are going to have to deal with the consequences of climate change. So I was here for Citizens Climate Lobby, Citizens Climate Education. Love to have you part of our organization. The website, just do a Google on citizensclimatelobby.org. And it'll lead you through joining up. So thanks, and see you later.